I mean, that's what they mean. The other line is
I used to format it in the meeting. I always make a little Alfredo like it. I was kind of surprised it came with any. I don't know my neighbors was not all of but they had right. Even lights there. Well, that night I think one time I say our stories from 19, which is really as good as it gets. Yeah. Usually it's running so. Yes, yes. And Joe is Joseph. I'm so light. Second. Globular clustering loads. Yep. Get them too. Sharing. All right. We'll be ready. Maybe half an hour, 45 minutes, something like that.
Good evening, everybody. Thanks for coming out to the June meeting of the DVAA. I'm Jan Rush, I'm the president, and we appreciate everybody being here and also everyone on YouTube. So in case you're wondering what strange nebula this is on your screen, this is a lovely photograph taken at a star party I went to with Bill McGeaney and his wife, Caitlin, and those are fireflies. So I love that picture. So we're getting into that season when we really don't have, I really can't tell you everything that's going on at these meetings. So really need to check out the website, but I will hit a few highlights. Our next public star party at Valley Forge is on Saturday, July 13th at 8:30 with a backup date of the 14th. And this is last week's star party. It was a beautiful night. And what was really nice was about half the people there setting up telescopes, maybe a third, were not members. They were people who just wanted to set up their telescope and use our venue. So it's great, yes. And we had a lot of you come out and I really appreciate your support. So we'll see you in July. Okay, a little bit of a shout out for Regional Star Party. These are just 4 that are coming up relatively soon. There are others in the newsletter and on the website. The first listed here, Green Bank, is coming up first, the earliest. It's over July 3rd through the 6th. And this is the field of the telescopes are kind of over here. But this is a trip I made with my daughter and she decided to fake this picture. This is a nice one because a couple of things are different at this star party, which make it worth the 6-hour-ish drive to get to Green Bank. First of all, the skies are pretty dark. They're pretty nice. They have wonderful courses in the afternoon and keynote speakers every night in an air-conditioned auditorium. So it's like worlds different from that pavilion that you're used to at Cherry Springs. It's like another planet.
It's got a radio telescope in her hand.
Yeah, yeah.
100 meter.
Right. The other thing about Green Bank is they have a dorm. So if you don't want to camp, you can buy stay in the dorm. Keep your stuff on the field, stay in the dorm. And they have showers too. So that's a good one to check out. And if anybody wants any more information about it, just let me know because I've been there a couple of times and I'll be able to answer your questions.
Did you have any fog?
No, I don't think we had fog.
Well, when I was there, it's like a natural bowl with like fog.
Yeah, it's kind of a, yeah. Yeah. I'm not saying every night was nice. I think, you know, it never is, but. Second one on our list is Stellafane, very famous, convention. If you'd like information on that, I'd say talk with, Tom Nolasco or Joe Lamb. I guess they've been there many times, right? Anybody else want to volunteer? John, maybe? Have you been there? Yeah, John Baleschmidt. Talk to them more about it. The Black Forest Star Party at Cherry Springs is September 6th through 8th. And this one, it will, oh, I forgot to check to see if registration was open. It's already sold out? Okay.
How long?
It only takes like an hour or two for it to sell out.
Yeah, 57 minutes for the Cherry Springs.
So you don't even know. Yeah, okay, so forget that one. However, you can still go to Cherry Springs at other times of the year. It's still wonderful, and there's always people around on the observing field if it's new moon. And finally, the York County Star Party, which is in Susquehannock State Park. A nice little regional star party that Jeremy and I and Bill McGeeney were at last week, I think, or 2 weeks ago, maybe. Yeah, 2 weeks ago. They're going to have one in the fall. They haven't set the dates yet, but that's another one that you should check out.
This is South Jersey, the end of September.
Yes, that was like, didn't fit on my slide, so it's a little bit further on. Yeah, so York County skies, 4.5.
20.6 on the SQN.
I could just barely see the Milky Way at like 2 a.m.
Little bit brighter, but not
Yeah.
bad.
John, yeah?
There used to be that most of the road where there used to be the airport, it's now over for first come, first served. It used to be that might still be, because it's not part of the road.
I don't know.
It's called the Night Sky Public Utility Field or something.
Yeah, so it's,
You
but
can't
you-
camp there.
you have to, there is a camping area across the street,
Yeah,
but you
that's
have to
sold
sign up for it, sold out, okay. And we also, I guess I should say now, DVAA rented the Big Dipper Lodge for that same weekend because it was open. Actually, it's Wednesday through Sunday. So, staying with us doesn't really get you into the party. But I'm guessing if you wanted to go over and, you know, check out the swap meet or the vendor tents, no one would probably kick you out. So it's about half a mile away. The lodge is about half a mile away from where the Cherry Springs field is.
How long have they done that, York County?
Well, it's kind of the iteration of one that existed
Mason
before.
Dixon Star.
Yeah,
But
so
how many years? Because I went to one and I think that might have been it. And simply over pop up out in the middle of the field, and if that's the one, I'm not sure that's the one.
Well, it was near Gillsburg for a while. And they both did.
it's had different iterations, so,
No longer under the York Club.
right.
Yeah,
Uh-huh.
at Green Bay, are you restricted from using your cell phone?
Yes, you can.
So
You can use a computer if you go inside the Faraday room, which is like a great experience. It's 2 huge doors and
Dan, are there slots open for the B&B thing?
D&D.
That you were talking
Oh,
about?
we're talking about? There are. We haven't posted it yet. We still had some fine tuning to do. And there are only like, I think like 7 beds, but we're allowed to camp on the field as well. So you can camp on the field and then use the kitchen and the bathroom and all that kind of stuff.
When will that happen?
Hosting?
Yeah.
Probably next week. Probably. So next thing I wanted to mention is Friday Night Lights. This was brought to my attention by Don Knapp, and who's the Merrill Chair. This is at Cheslin Preserve, which is in Coatesville, PA, Chester County. And some people have said to me, why don't we ever do anything with other clubs? Scott Bannerman. So this is a bunch of different clubs doing this. It's basically a family thing, food trucks, craft beer, music, and then our telescope set up all together. And if you bring your telescope, it's free along with 2 guests. So the tricky thing is Frank DeLucia, whoops, sorry about that. Frank DeLucia wants you to notify him by the 24th, so that's Monday. If you want to go and bring your telescope, that gets your name tag and tag for your guests, so you'll be able to get in free. Okay, outdoor picnic at Fort Washington State Park. This is a really fun thing we do every year. This year it's scheduled for September 13th and it replaces the September meeting. So this year we're going to do something a little bit different than what we did before. We did poster exhibits. This year we're going to do workshops. So you can sign up for a workshop on the topic you'd like. And everybody will be able to pick 2 workshops. We'll have 2 slots. And then that plus all the good stuff like food, lots of door prizes, courtesy of Skies Unlimited. And then when it gets dark, we do observing on the field, provided it's the weather's good enough. And everything is free, including the food. So put that one on your calendar. And I promised you I'd tell you which were the winning topics for the workshops. Thank you, everybody, for filling out the survey. This is the list of stuff, and the winning ones are in yellow. So eyepieces and filters, planning an observing session, getting started in astrophotography, upgrading your telescope, dark sky observing in regional star parties, and what to look for in the sky after you observe moon and planets. Now, I'm not sure that we'll keep all those topics, but probably most of them, depending on who we get to teach them. And these are the other things you wanted. So I really appreciate it when I hear from all of you about what you'd like to learn and what you'd like to hear more of. So we're going to take these topics and think about them for winter workshops. I think some big stuff. EAA is getting really big. Computerized control of telescopes. Look for some of those topics for our winter workshops. And we have a dark sky telescope clinic scheduled. Now this one, everything else is open to the public. This one is just for members. And the way this works is that if you want to sign up, you answer the questions that tell us exactly what telescope or binoculars you have and what questions you want answered. And then we match your telescope and your questions with someone who knows that scope and can help you out. And it's usually a ratio of 1 staff to 2 people. So it's really intensive help. And we'll be in Green Lane, so hopefully we'll have good weather. And you see, we're really serious. We have 2 backup dates. That means we're really serious.
It'll be like a 3-day hurricane.
Yeah.
Suppose you have a telescope that nobody else has.
We may not be able to help you. Sorry.
Figure it out.
Hopefully, yeah, hopefully we will. And we have a very exciting series of announcements today. Al Lamperti, who championed our youth awards program, was not able to be here tonight. He's at a wedding in Florida, but we want to announce the winners of our youth awards and present them with their checks and their certificates. So first of all, we have 3rd place went to, whoa, look what I did. 3rd place went to Elise Olmsted, and her topic was pulsar nulling. Brian, could you put the lights up a little bit, please? Did I ask you to come up, Elise? She won last year as well. Congratulations to you. And you are on your way to college this year? Yeah, where are you going?
I'm headed to Johnson.
Excellent. What major?
Some type of engineering, I'm not sure yet.
That's great. Well, we're honored to have you as a winner of our youth awards. Thank you.
Thank you.
Thank you. Okay, and second place to Iftikhar Peruno on effectiveness of calculating the redshift of quasars photometrically. And Iftikhar was also a winner last year. Thank you very much. I mean, congratulations. Okay, and and in a little while, Iftikhar will be presenting his research to us. So we're in for a treat tonight. I think our third winner is not here. I don't see Daniel anywhere. Okay, so we'll save his check for later.
I'm Daniel.
No money for you.
Yes, all winners receive a one-year complimentary membership in the DVA and a cash reward and an invitation to present their work at a DVA meeting. So you'll be hearing from them this summer. And we'd also like to, oh, I gave you the wrong one? Oh, okay.
Does he get the bigger check too?
You got a right picture. Got a right picture. Sorry about that. Now, this is really exciting news. Maybe put the lights down for this. Daniel Adivi won second place honors in the Astronomical League's Herkimer Parker Youth Imaging Award for his image of the Andromeda Galaxy. So the Astronomical League, that's 330 clubs all over the country. That's a huge award. And he gets $500 and a plaque. So great for him and a beautiful image. And there's more good news. Our newsletter, DVAA Amateur Astronomer, won the top prize in the Astronomical League. It's known as the Mabel Stearns. That's an issue by Tom Nolasco. I don't have a plaque. That's going to be coming later, but I just wanted to mention it, and maybe Tom, just stand up and be ready. He did win this once before. I looked it up. It was 2014. So maybe, yeah.
Carl.
Yeah, yeah.
The candidate mentioned that was unanimous.
It was unanimous?
The election of Tom was unanimous by AL.
Do you have insider information?
It's in the newsletter.
Oh, okay.
So yes. Reads.
All righty, and finally, I'd like to introduce our new junior board member at large, Sylvie Stonberg. She is here somewhere, yes? Stand up and say hello so everyone knows who you are. So remember, in December, we voted for changing the bylaws to allow a junior member on the board, and everybody approved it. And so we invited people to submit an application, and Sylvie did, and she was invited to join the board. I thought it was interesting that as I was churning through some old data from the church, from the club, back in 1977, there was a vote to allow juniors to join the club as members. And the fee was $10. Guess what it is today? $10. Zero inflation over all that time. All righty, let's now go to chair reports. You can bring the lights up so people can see you. Thank you.
Sylvia, you know this is not a paid position, right?
So Brian Lee going to tell us about new members.
My name is Brian Lee. I'm the welcoming chair for the DVAA. This month we have 10 new members. Joseph Noyce, Heinrich Ferry and Hyman Roeder, Jeffrey Bruin, Catherine and John Holtz, and David, Will, and Noah Henderson. I don't believe any of them are here tonight. Let's welcome them anyway.
We hope. Thanks, Brian. Okay, now I'd like to call on Joe Lamb for rentals.
Hey, folks, I just want to mention that we have a bit of good news. As you know, smart telescopes of various sorts have really come online in the last few years and increased greatly in popularity. And I'm sure several of you have them. The club has just purchased a C-Star by ZWO smart telescope for the rentals. So it's never been rented yet. I haven't taken a picture with it yet. I was able to download the app on my phone and command it a little bit, but I'm kind of a newbie at it as well. But if anyone would like to take a look at it and perhaps rent it, I'm available. So just see me and we'll get that going. Thank you so much.
Okay, we have an announcement from our astrophotography chair, Lou Varvarizes.
Hey, everybody, I'm Lou Barbarezzi, the astrophotography chair. Just want to let you know that we have a meeting once a month. It happens the Wednesday before this meeting. Everybody's anyone who's interested is welcome to join. Just click on the link on the calendar. You can see on the events page. Last month we had a guest speaker, Andrew Hitchner, who showed us how he takes landscape astrophotography. He did a very good job. A lot of people use when they first start astrophotography, they use this technique with just your camera, no telescope, and you'd be amazed at what a DSLR camera can bring out. At any rate, if you want to see that, all of our sessions are recorded on YouTube, so you can go to our webpage, check that out. The other thing I want to let you guys know is one of our members, he's a honorary member, Agapio Celia. He's a renowned planetary imager. He resides in the island of Cyprus. And the European Union just finished building an observatory there. They spent $2.8 million. They only have 2 telescopes, so I'm curious where all that money went. But I mean, I'm Greek, and knowing Greeks probably went towards granite or marble or something. Or at least to lift it 4,100 feet above sea level to the top of the mountain where it is. But at any rate, he's given us a tour of that observatory. It's open to all of us on Tuesday. Start time is 4 p.m. I'll log in around 1:15. The link is posted on the event page in the calendar. I also sent out the email at groups.io. If you guys look at that, you can just click on the link. I think it'll be pretty interesting. I'm very curious to see where that money.
This is this coming Tuesday.
Yeah, this coming Tuesday. And one more project that Mapios and I are working on that I'd like to pose to anybody who wants to participate. We're trying to put together a parallax project where we're trying to figure out the parallax between a GPS coordinate here versus one in Cyprus. There's a couple techniques we've come up with, but Andrew Hitchner proposed that we wait for an occultation. And then, we would have somebody with the same focal length telescope at both places, synchronize and, take images and see if we can calculate the distance. This would be a great extra credit project for any student in school who wants to come up with a methodology and how to work it out. And you don't necessarily have to wait for an occultation. We can do it with the moon and when the terminator crosses or what time. The key is to have everything synchronized correctly at the time. And there's an app called Dimension 4. As long as you get the same server, doesn't matter, I guess, you can use that to figure out. Yeah, Joe.
There's an occultation ones in January.
Okay, and now that's the other thing, the tricky part, Joe, it's always sunny in Cyprus,
Yes.
but it's not always sunny here, so we might have to make several attempts. So this doesn't have to stop at the first time. That'd be pretty interesting, to figure out. All right, anybody have any questions? Okay, thank you.
Thank you. Other announcements? Sure, here. YouTube needs to hear your voice.
Yeah, I'm not really gonna make any major announcement, but I just want to remind people, I think Sol gave a presentation on Peak Borealis, right? And so every clear night that I get a chance, I've been looking at Corona Borealis, looking right next to Gemma. Alpaca is also another name, to see if I could see a brightening of the star T. I haven't, but it's something that occurs every 80 years, and I've never seen a nova. I'm looking forward to seeing this one. I hope it happens by September, which is what they hope will happen. So just wanted to put that out there as a reminder.
You can get an alert from the ABSO, sign up
Okay.
for that.
Yeah, I heard that, I read somewhere that the ABSO, AA, American Association of Variable Star Observers, yes, had somebody looking every 13 minutes. I don't know if it's true, but that's pretty cool. All righty. Now we come to our presentation of the night. Iftikhar is going to tell us about his research project. Should you do this? Yes. And so this advances the slides. And this is the latest thing. Okay. Want the lights down or?
Yeah, we'll make it easy. Can we just keep them on for a minute? I'll take a couple of pictures.
So my project focuses on the effectiveness of calculating the redshift of quasars. And normally this is done spectroscopically. And normally this is done spectroscopically, but I wanted to find a more efficient way by doing this photometrically. Now, quasars are important in cosmological and astronomical research, as they exist as one of the farthest objects in the universe that we can view from Earth. And the way that quasars help is they harbor a phenomenon known as redshift. And calculating this redshift can be used within Hubble's law to find its proper distance from Earth. And through my research, I was able to reduce the error range of the distance within which a quasar lies within our universe and cut that by around 1/2. This means more accurate predictions could be made on not only the location of the quasar, but also the time period within which it existed. And I was able to achieve this at a 96.4% accuracy at 240 times the speed of spectroscopic method. And I was able to get better error rates than studies in this field. To start, calculating the redshift of quasars is essential because they help us answer multiple fundamental questions in both astronomy and cosmology. You can learn about how fast the universe is expanding, the age of the universe, how galaxies form, and much more. And quasars are distant luminous astronomical objects within our universe. They're powered by black holes and give off thermal radiation by heating surrounding gas and having a high redshift. And redshift is a phenomenon where the wavelength of light emitted from a given quasar is seen as highly stretched. And this causes a change in spectroscopy, which I'll mention now. Now, spectroscopic redshift can be viewed by putting the light from a quasar through something like an element. And if normally this is hydrogen, as hydrogen is a very common element in the universe, in our universe. And what happens is when you put this light through a spectrograph, the emission lines of something like hydrogen, they actually happen at a shifted rate. And then as you can see right here, that's an emission spectrum of a object that is not moving, and then the one at the bottom is of a quasar. And because these quasars are moving away, the wavelength at which the emission lines happen, they're stretched, which causes them to happen at a shifted rate. And you can use the shift to calculate the redshift, and then you can use the redshift to find its distance. And this is spectroscopic redshift. And in my project, what I did was find the photometric redshift. And photometric redshift relies on using different wavelengths of light and their frequencies. And for my project, I used the UGRAZ light magnitudes, which happen at different wavelengths, shown here. And the advantage of using photometric redshift rather than spectroscopic redshift is the photometric redshift can be done much faster. Because what can be done by spectroscopic, the rate that it takes for to calculate the spectroscopic redshift, it takes around 1 to 2 hours. But that same process can be done by photometric methods, but in 15 to 30 seconds. For my project, I gathered light magnitude data and redshift data of quasars from the Sloan Digital Sky Survey. These are the people that use an optical telescope to gather both the redshift data and the light magnitude data. And this is sent out as public information, so it's very easy to gather. And for my project, what I did was I split up my data into 20% testing data and 80% learning data. And what this would allow me to do is for each of my different methods, I could train the model on 80% of the data and then test on the remaining 20% to see if the model is making good predictions. And for my project, I tested 4 different methods. And the first method was the regression method. And this is a pretty standard use of an equation what I did was through Microsoft Excel, you can actually access a regression tool. And if you give it the input variables and the output variable that you want, it would give you the best equation possible to relate them to get the best predictions for your output value. And for me, the equations looked something like this. And you can also do this because you can also do a quadratic regression where the terms are squared to see if that makes a significant difference. There's also another method that I tested. It's known as the grid method, and this relies on the closest quasar values. And how this works is for a given quasar's UGRIZ values, what you do is you subtract the U value from the G value, the G values from the R value. And the reason why you subtract them is so that you get smaller values around 0 and 1. And what you do is you graph these values against each other into 3 different plots. And then you split up the grids. And then within each individual grid, you look at all the quasar data contained within it, and then you take the average to get a predicted redshift value. And you do this for each of the 3 graphs, and you average those to get a prediction. And next, another method that I did was the query method. And how the query method works is from the query itself, where you gather the data, you can actually set parameters on what type of values that you want. And how the query method works is for a given quasar's UGRIZ values, if you know them, then you can actually set parameters a little above and a little below each of the values. And then you can look at all the quasars that meet that criteria and check to see if the redshifts are close to each other. And this way, for example, right here, I use UGRIZ values. And then as you can see, because the UGRIZ values are close to each other, the redshift values are also very close to each other. And I'll speak more about the query method later. And moving on to modern techniques of redshift predictions. With the development of machine learning and AI, a lot of researchers are actually using a machine learning tool to predict redshift. And for my project, I used a very basic machine learning, very basic neural network consisting of 3 layers. And how this neural network works is for the input variables, what it does is it tests different equations at each layer and tries to lower something known as the error. And how it does this is it takes the derivative of the error function and tries to reach a local minimum, which means the best possible lowest amount of error that you can get. And this is the neural network. I'll speak on another machine learning method that has been tested later. Moving on to trials, what I did first was I gathered 1,000 quasar data. This meant around 800 were used as learning and 200 are used as testing. And as you can see from the graphs here, the first graph is the linear regression method. The second one is the quadratic regression, and the third one is the grid. Now, because the x-axis is the actual spectroscopic redshift, and the y-axis is the predictions, what you would ideally want is a straight line, y equals x line, but we don't really see that, which means there was something wrong with either gathering the data or the methodology used. And what I did next was I increased the amount of data that we were using. I used 40,000 quasar data next, and as you can see, the results weren't much better. And one of the key points to consider here is that the redshift data from the Sloan Digital Sky Survey, most of their data is actually using photometric redshift estimations already. And this is counterintuitive because you'd want to teach it on actual known data first and then test on some unknown data. And so there is a way to actually set parameters within the Sloan Digital Sky Survey to get only the data that has been measured the most precisely. And so what I did in my next trial was I only use data that had been measured precisely. And as you can see, the graph looks much better, and not to mention the grid method also looks much better. And from this trial, I only used around 600 quasar data. And I wanted to increase that, but something else that I noticed was that when you gather the redshift data from the Sloan-Dill Sky Survey, there is actually an unequal distribution of redshifts, meaning that there's more redshifts between 1 to 2 than there are between values like 3 to 4. So for my next trial, what I did was I used an equal distribution of redshift data so that there's an equal amount of redshifts between 0 to 1, 1 to 2. And this makes it so that there's no bias in the predictions that the model is making. And this gave me the best grasp that I got. The first one is the linear regression method, and the second one is the grid method. Next, what I did was I tested the machine learning methods. And for this, at first I tested around 50,000 quasar data at once. And this was actually done pretty fast because the machine learning method doesn't take as long as something like a grid method, because for a grid method, you'd have to look within each grid and then find the average redshift. And as you can see, the graph looks much better, but there's a lot of outliers in the graph itself. And a way to fix this is actually to split up the model itself, so that if you know the range within which a quasar's redshift lies, you can only use that only that range of redshift predictions. So how I did this was I split up the model into 4 parts, so that each model would make predictions between only that area. So this first model would only make predictions between 0 to 1, and this model would only make predictions between 2 to 3, 1 to 2, 3 to 4, and so on. And what this allows us to do is it allows us to get rid of all these outliers that lie in the quasar prediction. And after you do this and you combine the graph together, you can actually get much better predictions. But something to realize is from the beginning, you can't actually know which redshift range the thing falls within, which is why the querying method actually comes in handy, because if you know the UGRIZ values and you use the query to find the redshift values within which it falls, within which it's close to, you can actually use that as a classification system to know which model to use. And that allows you to actually combine the graph and makes it a valid method for prediction. And the combined graph is very close to the ideal graph that we'd want. And the errors, the root mean squared error for this model is much better than what's been done in the field. Another machine learning model that I tested was the random forest model. And this is a bit different than the neural network, in which within a random forest model, you actually teach smaller models known as trees. And each of these trees becomes specialized in a small range of values. And this makes it so that there's less outliers overall. And as you can see in the graph below, compared to the neural network model, the random forest model is much more compact and much more together near the y equals x line. And the root mean squared error for the random forest model is similar to the neural network. And what you can then do is actually, what I did was I tried to combine the two models to see if that would give me any better results. And while there is a slight improvement, it's not significant enough to where you'd want to use both models at once. Next, the significance of discoveries. Comparing my root mean squared error and my other errors to studies that have been done in the field, I was able to reduce the error range within which a quasar lies by around 1/2. And what I mean by this is by using the mean absolute error, which tells you the average amount of error between predictions and the actual values, you can actually calculate the error range of which the quasar may lie. So that if you predict the quasar is here, it can be shifted a little bit here or a little bit here, but you don't know that because of the error. And this is actually very easy to calculate because the error actually stays constant no matter the distance of the quasar. Meaning that in Hubble's law, because we know the speed of light and the Hubble constant, you can actually find the error distance by this equation if you just know the mean absolute error of the redshift predictions. And comparing this to the most latest study of redshift predictions, which have been done by Dr. Zhang, he was able to reach a mean absolute error of around 0.1843. This meant an average error of around 749 megaparsecs on each side, meaning a total of 1498 megaparsecs, which can be seen here. But in my research, I was able to reduce this error range by around 1/2. And I was able to reduce it to around 731 on both sides. And also comparing the root mean squared error, which is another way of calculating the significance of predictions. Right here is the regression method, and you can see the root mean square error is very high. And similarly for the grid method. But for the machine learning method, my root mean square error was lower than one of the top researchers in the field, Dr. Antonio Diasanto and Dr. Kai Polster. They have been trying to attempt photometric redshift estimations for a really long time. And I was able to actually get their help in verifying my results and my methods. So in conclusion, with my research, I was able to make better predictions on the photometric redshift of quasars. And this is significant because quasars are so distant and they're one of the most distant objects that we can actually see. And because they're one of the most distant objects we can see, we can actually use them to find something like the Hubble constant or the age of the universe and many other fundamental questions within both astronomy and cosmology. And the tools that I used were very basic tools, just Microsoft Excel. I used a basic Python compiler, the Sloan Digital Sky Survey, and the Sloan Digital SQL, which is the query itself. And special thanks to Dr. Kai Polster for allowing me his guidance for my project and verifying my methods and my work. Thank you.
Cool.
Any questions?
How'd you come up with the ideas that, for this topic?
There's actually a really cool story for that. So my teacher, Miss Burns, who runs the science fair department in our school, she actually showed me an article on a team known as Gaia. And they're actually actively trying to use these quasar distances to accurately map our universe. And they have actually had a comprehensive list so far. But in their research paper, I read that around 60% of their redshift data that they use to actually find the distance of these quasars are actually photometric redshift, which means they're not accurately measured. And because photometric redshift estimations by this time is very inaccurate, I wanted to see if there was a better way to get more accurate predictions for redshift. And that made me pursue this project.
Great. Any questions? Is that Roseanne Burns?
Roseanne Burns, yes.
Great.
Yeah, she is. Thank you.
Well, thank you so much. We're all much smarter now. In high school for another year, or are you going to college as well?
2 more years.
2
I
more
will be a
years.
junior.
Ooh. Ooh, look out, world.
Thank you.
Okay, time to turn the program over to our programs chair, Jeremy.
All right, thanks, Jen. I'm gonna start with a little update on upcoming programs. Since in July, we're gonna have Isabel Hunt from STSCI, so she's gonna be talking about operations on the James Webb Space Telescope. So how do they decide what to observe and when? How do they keep in contact with it? How do they keep it in its proper orbit? All that sort of stuff. In August, we're going to have Ed Sion from Villanova University, and he's going to be talking about cataclysmic variables, including T Corona Borealis. So I tried to get the over-under from him on whether it'll go off by then, but I think he said he doesn't know any more than any of us. I guess we sign up for the AAVSO alerts, and then we'll know within 13 minutes. Yeah, we could check on Predicted and all the other sites, see what people are saying. So let's see, in September, we're going to have the Fort Washington meeting, which is still under preparation. And in October, actually, we just got this settled out recently. We're going to have Jamie Rankin from Princeton University. She is the deputy director for the Voyager missions. That'll be kind of fun. We'll hear from that. Tonight, we're very happy to have back one of our returning champions, Ray Harris from the Lehigh Valley Amateur Astronomical Society. Now, Ray wrote a great bio, so I don't think I can top this, so I'm just going to go through it. Ray Harris is the son of a career naval officer. He grew up mostly near naval facilities in Virginia and California, and actually graduated high school on the naval base in Guantanamo Bay. You'd say you went to Guantanamo. So he attended Yale University, and after graduation, spent 5 years in the Navy, supervising nuclear reactor operations on a submarine. He left the service for a career in civilian nuclear power. He joined PPL in Allentown in 1980, and he was supervising the Susquehanna nuclear power plants up in Berwick. He later moved into corporate IT before retiring in 2009. Now a little astronomy. In 1984, Ray bought a C8. He joined LVAS in 1985 and began exploring and photographing the night sky. And this was back in the bad old days of film photography. Right, so the days of ships of wood and men of iron back in the day. He had a photo of the Horsehead Nebula, which appeared in the January 1990 Sky and Telescope. So he has also had 2 articles published in Sky and Telescope in January 2022 and in February 2023, both on the history of celestial cartography and history of constellations. So Ray was here last, was it last year? Last year. Yeah, as last year he told us about the history of celestial cartography, and tonight he's back to tell us about the lost constellations. Well, please join me in welcoming Ray Harris. Here. Testing.
Close enough.
Let's make sure this is working. And here's your clicker. We actually have the same clicker, different brand, but same factory in China. You know, it works in reverse.
Okay, we want to turn some of the lights off. Thank you. Constellations, we all know what they are. We know that we like finding objects in them. They're just an artificial construct. They're something that humans produce as a two-dimensional overlay of a 4-dimensional sky. I say 4-dimensional because the stars that are farthest away may not be where we think they are. So it's really not just 3-dimensional, it's 4, time is included. We have 88 constellations today. Where they came from is a mystery to many of us, and we're going to find out about that today. And along the way, we're going to learn about a bunch that got invented or created along the way and are lost to us, no longer extant. So right button, there we go. Our 88 constellations today were created by the International Astronomical Union to get rid of the chaos in the sky. I say chaos because the formal declaration of what constellations there were and their precise boundaries was needed because when they named variable stars, they were named for the constellation they were in. And so we needed to have that information. And so the International Astronomical Union came up with a list in 1922 of 88 constellations they wanted to formalize. They settled on the boundaries in 1928, and they published all that in 1930. And it has been our official list of constellations ever since. But where did these 88 constellations come from? Well, Ptolemy's Almagest in the 2nd century identified 48 constellations. And those 48 constellations were really the Bible for people in the Renaissance Europe as they were deciding how to portray the heavens on early charts. The different cultures around the world all have their own star lore. I like to say that in Japan, Suba is star and Subaru is their name for the Pleiades. And if you remember the old logo for Subaru, it used to actually look like the Pleiades. That was one of their constellations. For us, it's just an asterism. It's part of a constellation, Taurus. Anyway, these 48 constellations were what we started with in European astronomy. And Western European astronomy ended up essentially influencing the final worldwide use of constellations. All of these except one survived to the cut made by the International Astronomical Union. The one that didn't, of course, was Argo Navis. We have no constellation Argo Navis, but you will find Argo Navis on just about everything published prior to 1930. It's only in 1930 that it pretty much got wiped out. And we'll learn about why. Anyway, this chart from 1603 shows Argo Navis, and it's our first lost constellation. It was a very large constellation in the southern sky. The first star charts, as I told you last year, were created around 1515 by Albrecht Dürer. And you'll notice here we have a lot of empty space in the sky, especially around the southern pole and other areas in the southern hemisphere. And when people wanted to create globes, they really wanted to fill these in, globes and charts, with more information, and they sought ways to do that. So the first editions were by a guy named Caspar Vogel. In 1536, he produced a globe, and he added 2 new constellations. One of them is Coma Berenices, and it shows up in the 1603 chart by Bayer right here at the foot of Ursa Major. But it's interesting, even though it's included on this chart, it shows up as a sheaf of wheat on the with the constellation Vouta, so it wasn't even consistent. Vogel didn't invent Coma Berenices. It was described by Ptolemy as a cloudy area, and so it really goes back to Ptolemy, but Ptolemy never considered it a separate constellation. So this was our first edition from Ptolemy, but actually introduced by Caspar Vogel in 1536. And this chart in 1730 is the only time it ever got its own chart all by itself. It usually just appears with other constellations. The second constellation that he introduced was Antinous, right below the Eagle. The constellation was also described by Ptolemy, so it again was not a new constellation, but it was he always considered it as part of Aquila. Anyway, Antinous, did not survive. It was on almost every chart up until about the early 1900s. And it was only when the IAU formalized the constellations that it disappeared. And so this is the way it normally shows up, literally at the foot of the eagle. And so Aquila is the constellation that it's associated with. And it shows up as its own again in that 1730 atlas is the only time it got star billing on its own. So this is our first modern constellation to have been lost to us. In 1589, a man named Petrus Plancius, who was producing maps in Amsterdam, decided to produce a globe, and he didn't like the fact that there was a big empty area in the south, and he wanted to fill some stuff in, and he'd heard about some constellations in the south, a triangle and a cross, and so he just stuck them in there, and he invented this crux and what he called Triangulus Antarcticus. And you'll notice that crux and triangulum are not where our current crux and triangulum Australia are. Here's crux here. We have it, and actually the stars for it show up in the feet of Centaurus. So here's where our modern crux is. And those two were introduced merely to give some decoration to the southern sky. Those were very quickly lost to us in about 1598. We'll talk about that in a minute. In 1592, he added two more. He added Polophylax, the guardian of the pole, and Columba, the dove, right near what he called, instead of Argo, Navis, he called that Noah's Ark, Ark of Noah. Anyway, those four constellations of his in 1592, he added the other two, and of those, Columba did survive to present times, and so Columba is our next invented constellation, and the other three were lost to us. Why were they lost to us? Well, he wanted a better charting of the southern sky. He knew he didn't have the real information on what the southern sky looked like. So Petrus Plancius actually trained a couple of Dutch navigators to go chart the southern sky more accurately. And when they came back and gave him their results, he had 120 new stars in the southern hemisphere from which he formed 12 new constellations. And he abandoned his Polophylax and he abandoned his crux and his triangulum and replaced them with these new constellations, including a new triangulum. These 12 new constellations in 1598 were quickly adopted by others. And in fact, Bayer's famous atlas of 1603 included a chart showing these 12 new constellations in the southern sky. He also, Petrus Plancius, moved crux into the feet of Centaurus. And so he actually introduced that one. Although, again, Ptolemy had described this not as a constellation, but as an asterism within Centaurus. But it did get carved out from 1603 on as a separate constellation in the southern sky. All 13 of those, the 12 in the southern sky plus crux, were introduced by Petrus Plancius and have survived to modern times. He took a little break, and then in 1612, he introduced 8 more constellations. Of these, only 2 survived. You may be familiar with Camelopardalis and Monoceros. The others are lost to us. They were popular for a while, but by about 1730, they were all gone. So here is a chart from 1660 showing this is from a famous atlas I think I told you last time, there's a copy for sale. If anybody wants one, it's about $350,000. It's quite impressive, but we have, it's got 30 charts. And on this nice chart of the northern sky, we can see some of these constellations that Petrus Plancius introduced. And we'll dive in and look at them a little closer, but there's Jordan River, there's Tigris River with Euphrates as a tributary. We have Apis, the bee, in the north. He had also introduced Apis, the bee, in the southern sky, which morphed into what we now call Musca. But Apis, the bee, became Musca, the fly, in the southern sky. This is Apes, the bee, A-P-E-S instead of A-P-I-S. And it also eventually morphed into a fly. And it's interesting because there's lots of charts that have Musca identified both on the north and the southern sky. Anyway, that was one of them. He also introduced Camelopardus, and he introduced Sagida australis and Cancer minor. There's Sagida again, Austral, and he introduced Monoceros, and down here at the foot of Monoceros, Gallus the rooster. So if we take a look a little closer at some of these, so we have the Jordan River originating in the mountains Jor and Dan, and pretty much circumnavigating Ursa Major. We have the Tigris River with the Euphrates as a tributary. Here south of Cygnus. Cygnus, this is actually south is up here. So that's south of Cygnus, running above Aquila. We have Apis, the northern bee, right above Aries. It's really considered part of Aries, but he carved it out as a separate constellation, Apis. And we're going to talk a bit about those 4 stars and what happened to them. He introduced Cancer minor. And he introduced Sagida austral. And Monoceros, and of course, Gallus, the rooster, down here near Argo. The next introduction of new constellations is one we'll just kind of mention on a side to. Julius Schiller published an atlas in 1627. I talked about it last summer. He Christianized the sky. He replaced everything with new constellations. So the zodiac became the 12 apostles. The southern sky was populated with constellations from the Old Testament. The northern sky with constellations from the New Testament. If it had never been copied or mentioned by anybody else, I wouldn't have even talked about it, because anybody can come up with something, but if nobody else adopts it, it's meaningless, right? However, Hilarius and gave equal time to it and published all of the Schiller constellations in addition to the Ptolemaic and Petrus Plancius constellation. So here we have not north and south, but kind of east and west, showing the planispheres of all the constellations. And of course, that's not Argo Navis, that's Noah's Ark. But those have all been lost to us. None of the constellations Schiller have survived. Following Petrus Plancius's new constellations, he introduced 25 constellations overall, and 16 of them have survived to modern times. 9 were lost to us. We've talked about those. Well, in the next 66 years, other men got in the act and introduced some new constellations, and none of them were as prolific as he. Only 1 for each of them. They limited themselves to 1 new constellation each. And so we're going to look at these. Isaac Habrecht introduced in 1621 the constellation Rhombus, deep in the southern sky, near the southern pole. It was not really too popular, but it was adopted by a man named Coronelli who made lots of charts and globes in the 1690s. And its last appearance was in 1730. So it was a popular one that was adopted by a few people, but not on most charts. Jacob Barsh in 1624 kind of did something with Apis bee. He turned it into Vespa the wasp. So the bee became the wasp. And except for one chart I'll talk about, nobody else ever adopted Vespa. Francis Lamb in 1673 introduced Cor Caroli, which is really just a single star in what we now call Canis Winatici. And I'm terrible with pronunciation, so you'll pardon me. Anyway, that one was very popular and really lasted until about 1900. So once it was created, it was a very popular one. It didn't appear on every chart or atlas, but it was on the major ones. Stanislaw Lubinecki in 1665 published a whole bunch of charts showing the paths of comets through the sky. So it wasn't really an atlas, but just showing the paths, and he'd show whatever constellations appeared. On most of his charts that showed Aries, he included Apis the bee from Petrus Plancius. That's on most of his charts that showed Aries. On one, he showed Vespa the wasp. And on this one, he showed Musca the fly. And this is the first time I've ever seen Musca on a chart. Most references I've seen attribute Musca to a morphing of Apis the bee and the Musca the fly in the next decades, in 1687, in a famous atlas by Hevelius. But clearly, the idea preceded Hevelius, because here it is 12 years earlier on a chart by Lubinecki, although, like I said, he tended to favor Apis and then just threw in one Vespa and one Musca. Anyway, none of those survived. And Ignace Gaston Pardis in 1674 threw out Apis and Musca and Vespa and replaced them all with a fleur-de-lis, which he called Lilium, or on this Italian one, Giglio. But the fleur-de-lis, same group of stars, same spot in the sky, different constellation. This one was fairly popular and appeared on about half of the works between 1674 and 1730, and then disappeared for 50 years until it was resurrected on two French charts in the 1780s. So the French probably thought, hey, that fleur-de-lis is kind of a good idea. We'll throw that back in there. But that was it. So it hasn't appeared on anything since 1789. So Apis the bee, Vespa in the same spot, Musca in the same spot, and Giglio have all departed and are lost to us. Although Musca pretty much survived on most works right up until about 1900. Edmund Halley got in the business here and introduced the constellation Rover Caroli to honor King Charles, the oak that he hid in. He introduced that in 1678 and right on the nose of Argo. And it was very popular and showed up on very great many charts right up until about 1900. And then the IAU axed it, and it's lost to us also. But it was a very popular constellation. Augustin Royer in 1679 introduced Septrum, and it's pretty much where we have inserted today. It was adopted again by that Cornelli guy in the 1690s and pretty much ignored by most others. but did appear in that weird atlas from 1730 where it made its final appearance.
Right, can I ask a question about projection, like? Seems like we're going back and forth sometimes with looking down at the celestial sphere and looking up at the celestial sphere.
Actually, I usually I take these so that the lettering is right side up, but on a planisphere that's centered on the north or south pole, when you're looking at the top half, you're looking at everything upside down. So it's just a matter of the perspective of the charts. I could have done it so that south was down, but then all the lettering would have been upside down.
I'm just wondering, is there a term for the looking down versus looking up at the sky, the plates?
Oh, if you're talking about the perspective of the, okay, yes. Some of the charts were geocentric, meaning they plotted the heavens as if you were standing on the surface of the earth looking up at the heavens. When you look at a globe, it's the opposite. The earth is at the center of the globe. You're external. That's an external view. And so everything's reversed. So I think that's what you're asking.
Yeah.
So that was also popular for flat charts. They published them as if they were the surface of a globe that had been flattened out. And so you'll see things swap back and forth just by the preference of the cartographer who made the chart. So Septum disappeared. Godfrey Church introduced Brandenburg scepter in 1688, and it was ignored by everybody for 100 years. Nobody paid any attention to it. I probably wouldn't have even talked about it, except a guy named Bode in 1782 grabbed it, put it in his charts, this chart from 1782, and it was on everything from then on. So it was a very popular constellation right up until 1900. But it was a 100-year gap, almost a 100-year gap after it was invented, before anybody included it. In 1687, Johann Hevelius produced an atlas that actually didn't get published until 1690, posthumously by his wife to help pay the bills. He introduced, I'll say 10 here, although there's some argument over, he labeled a few other things, so you could probably get as high as 12 or 13. But he introduced some new constellations. And some of these stepped all over those of Petrus Plancius. And so those disappeared on Hevelius's atlas. And 7 of these, the ones that are highlighted in yellow, have survived to modern times, and a few are lost to us. I didn't mention a few others. I'll just say things like he labeled the head of Medusa in Perseus. And some people say he therefore created a new constellation, but not really. It's just Perseus's arm holding her head, and he still does today. So here's his new constellation Vulpecula, and Answer, the goose, which has been lost to us. But it was very popular pretty much up until 1900. Anything Hevelius produced got adopted by a guy named Bode in 1801. Bode tried to adopt just about everything. So Hevelius included all the constellations in Bayer's Atlas of 1603. This is 1690, or 1687, depending on how you think of it. But anyway, he included all those plus 2 from Petrus Plancius from 1612, and then a whole bunch of new ones of his own. Very popular atlas, and so a lot of his stuff survived. Mons Menelaus was just a mountain at the foot of Bootes. Triangular Minus made its first appearance here. He invented that one. Notice here's Musca. Apis morphed from bee into fly. And on his chart, there's a Musca in the north and a Musca in the south, and that was true of a great many charts from the 1700s. Now, in 1730, a lot of these things that had been adopted and not included in Hevelius's atlas made their final appearance. So 1730, Jordan River made its final appearance. The Tigris River made its final appearance. Rhombus made its final appearance. Septrum made its final appearance. Lilium made its final appearance, except 50 years later, I told you a couple of French charts throughout Musca and put that in. And that was about it from 1690, 50 years, no new constellations got invented. The first new one after Hevelius, it's actually 65 years later, was in 1743, Wren, the reindeer, right there near the pole. Wren the reindeer was popular, again adopted by Bode in 1801 and therefore survived until about 1900. In 1755, a guy named Lacaille introduced 14 new constellations, these and these two. So the 14 that are not highlighted in color, he introduced those and he crammed them in the southern sky around Petrus Plancius's constellations. He didn't replace any of Petrus Plancius's, he just crammed them in around those. All of those have survived to today. He also, 9 years later in 1764, introduced Carina, Puppis, Vela, and Malus. Those were not popular. Malus disappeared pretty quickly. A few people mentioned the other three, but what these were, this was the breakup of Argo Navis. So it's Carina the keel, Puppis the poop deck, Vela the sails, and Malus the mast. So he broke Argo Navis into pieces. It wasn't real popular. It was adopted in a very few places, and Argo Navis survived right up until when the IAU was formalizing things. The IAU looked at the sky and said, Argo Navis is a massively huge constellation. We have to do something about that. And they just stepped back to the suggestions of Lacaille in 1764 and said, well, we kind of like that. And so they carved Argo Navis into Carina, Puppis, and Vela and set formal boundaries for it. And so that's how Argo Navis got killed. And although Lacaille's constellations were not popular and not adopted by most cartographers, the IAU resurrected his constellations and formalized them in our sky. Here you see a chart from 1790 showing all of these constellations in the southern sky that got crammed in and around the ones that Petrus Plancius did, making it a pretty crowded area. You can also see how big Argo Navis is and why it got later broken up. After Lacaille's efforts, a few more people got in the act in the late 1700s to introduce new constellations. In some cases, they introduced more than one. Lalande was especially prolific. He liked to come up with things. Maximilian Hell did a couple, and Bode did one in 1768 and a few more later. But we'll look at each of these. So I talked about Brandenburg Scepter, which he had Bode adopted, but he also introduced George's harp. And this is right under Taurus, and near Eridanus. So anyway, George's harp got introduced by Bode, and because it was his atlas of 1801, this is 1782, but his great atlas of 1801, he kept it and everybody else copied it, and so it survived pretty much until 1900, and then has been lost. he introduced Custis Messian, really the guardian of the North Pole, and as a shepherd. And I thought it's interesting that he put it with Ren the reindeer, so I'm not sure if he's shepherding the reindeer, but Custis Messian was included in Boda's atlas. It was invented by de Lalande in 1775, but de Lalande didn't chart things. He just kind of fed his information to Boda, and Boda charted them. So it became ensconced in Boda, and then by everybody else until almost 1900. Lemonnier in 1776 introduced a new constellation, the Solitaire, on this chart. This is actually the chart that he introduced it on, showing this new bird in the sky. Again, Boda adopted that, and it was right down here under Libra and near the tail of Hydrus. And because Boda adopted it, then it got pretty much included in everything up until about 1900. So the Solitaire is lost to us, but it was popular for quite a while. Poniatowski's bull, introduced by Martin, and I'm gonna guess it. Hoshbut at the name, but anyway, he introduced Poniatowski's bull in 1777, and it again was adopted by Boda and others, and it pretty much survived until about 1900. Didn't make the cut by the AIU, so IAU, so it's lost to us also. But it was a very popular constellation for over 100. Here we have Frederick's Glory, hard to see on the slide. There's a crown and a quill and a sword, and that's pretty much right where Scepter was, and crowding out Lacerta that got added by Hevelius in 1687. So this is 1787, and Boda introduced this himself. So it's all his charts and everybody who copied Boda up until about 1900. Maximilian Hell introduced two constellations to honor Herschel's discovery of Uranus. He introduced a large telescope and a small telescope. Interestingly, he introduced them both in 1789, and a bunch of atlases show one or the other, but there isn't any atlas that shows both. So it got picked up by Boda, and this is right above Gemini. And this is the large telescope, and so Boda adopted it, and it pretty much lasted until about 1900. The small telescope, Herschel's small telescope, down here at the between Orion and Taurus. This is a chart from an atlas published in France in 1795. You can give it away because the words are in French. Anyway, this one I found interesting because I own this chart, and I discovered that the telescope is pointing kind of at a star that's underlined and labeled Herschel. So Herschel's little telescope, and here we have a star named Herschel right on the ecliptic. Any guess what that is? Sure. Uranus. That was the original name for Uranus. Herschel discovered it in 1781, and it was named Herschel or other things at different times. And the name Uranus didn't come in for quite a while, decades. Anyway, I thought it was interesting, and I thought, well, you know, why would you show a planet on a spot on a chart? Because you use the chart over different years and the planet moves. So I said, well, that must be where it was in 1795, or maybe where it was discovered by Herschel. And I did some calculations, and it was way off. And I thought, why the heck is it here? And then I did some backward calculations and said, what date does that represent? And it turns out it represents 1690. And I did a little more research and discovered that Boda got to be fairly famous because he was the first to calculate an accurate orbit for Herschel's new planet Uranus. And the way he did that was he discovered that Flamsteed had seen it in 1690 and recorded it as a star, but had not realized it was a planet. And so this honors Flamsteed's observation and technically discovery of that planet in 1690. Interesting that that's why a French atlas, they honored a guy named, a Brit named Flamsteed, with that showing up on the chart. But it took me a while to figure that out. Anyway, that constellation obviously was lost to us. It only appeared on this one chart in the French atlas and in a German chart that was published in 1899 and reprinted in 1819. And those are the only three places it ever appeared. So it's lost to us also. Here's one that I think is interesting to many people. Lalande introduced Quadrans Borealis here near Draco. And this constellation was popularized by Boda again and stayed with us until 1900. It survives in one way. If you're familiar with meteor showers, they're named for the quadrant of the radiant for the, when you look at a meteor shower, it appears the meteors radiate out from a point in the sky. The point exists in a constellation. So we have the Taurid meteor shower, we have the Lyrid meteor shower, we have a bunch of showers named for where the radiant is, the constellation it's in. Well, the quadrantid meteor shower is named for the radiant that was in Quadrans Borealis. And we still call it the quadrantids, even though the constellation got axed. So we've lost this constellation, but it stays with us because that's where the radiant is for that meteor shower we see each year. In 1801, Boda issued this great atlas. He included everything that Hevelius had included in his atlas. He included everything that had been invented in the 1700s, except for that small Herschel telescope, and he didn't break up Argo Navis. But then he also introduced 5 new things on the atlas. So the 2 of them had been proposed by de Lalande. De Lalande came up with lots of ideas and threw them out, and if they stuck, Boda published them. So here we have on one of Boda's charts, Felis the cat. We have Locum Funis, which is a tool that I'll show it better on another chart. It's a tool used by sailors to estimate ship's speed through the water. And here we have movable type. So those 3 constellations got added by Boda in 1801. Here's Locum Funis. And you can see it kind of winds all around. Boda, by the way, in 1801 was the first to add boundaries to constellations. So you can see boundaries around the constellations. He was the first to do that. Until then, there weren't any boundaries and people were free to carve out whatever they wanted. So he kind of carved things out and said, okay, here's where the boundaries are. His boundaries were not precise. And obviously the IAU felt they had to be, and so all their lines are nice straight lines based on the coordinates and the epoch of 1930. They're no longer straight lines for us. They're straight, but they don't follow the grid lines because, of course, precession of the poles. The other 2 that he introduced were the hot air balloon and the electric machine. And these were all crammed into the southern sky around all the other ones that between Plancius that had stuck in there and then LaCale had stuck in. But those were all five of those are lost to us. Very little happened in the 1800s. There was only one guy who introduced new constellations that got adopted by anybody. In Jameson's Atlas of 1822, he introduced Noctua the owl on the tail of Hydra. Solitaire was not shown. It would have been right here, so he could have had it. But Noctua the owl, and if it hadn't been adopted by another guy in 1835, I wouldn't even talk about it. But he also replaced reticulum with solarium. And the reason I mention those two is because those two were adopted in an atlas by a guy named Burritt. And Burritt published the first American star charts, and his atlas was popular in schools for about 3 or 4 decades, all across the US. And so it was a teaching tool for students in the US that they knew these constellations. Well, that's pretty much it. We've seen a lot of constellations that didn't make the cut. We'll review the ones that did. Ptolemy introduced or documented 48 constellations. 47 of those survived. The roots of those are pretty much lost in antiquity. Some we can trace back further than others, but we pretty much attribute them to Ptolemy. Vogel introduced 2 constellations in 1536, one of which, Coma Berenices, has survived. Plancius introduced 25 constellations. 1 survived from 1592, that's Columba, a bunch in the southern sky in 1598, and then just 2 from his group of 8 in 1612. He ends up with a total of 16 constellations. Hevelius introduced 7 in 1687 that have survived to modern times, and LaCale introduced his big 14 in the southern sky in 1755, and then his suggestion to break up Argo Navis into 3 in 1764, and if you add that up, it's 88 constellations, and that's where we get them. Any questions? Not as technical as that gentleman is. No math.
How do you think the IAU made the decision about what to keep and what to jettison?
It was the big political thing, but they pretty much put it in the hands of one man, and I don't remember his name. So he pretty much did it, and then he proposed it, and some people, I guess, argued a bit, and then they voted on it and accepted it. So they charged him with doing it.
Some of the ones that got dropped were so much more interesting.
I like rhombus. But can't see it from here. Yes.
If you could wait for the mic so that the people on YouTube can hear.
I'm often amazed at how unfamiliar the artists were with the actual animals. It looks less like a fox and more like an anteater. Tails. And you think maybe it's because they were just unfamiliar with the animals themselves. But I mean, like right there in the chart, Cancer is a lobster instead of a crab. And Musca's got 4 legs instead of 6. You would think that at least they would be familiar with house fly. But it's interesting about the confusion between the crab and the lobster, because right here on Lancaster Avenue nearby near Manila's, there's a seafood store and a big sign with a lobster on it that says crabs.
I think I told you after last year how it kept alternating between major atlases. One would have a lobster, one would have a crab, the next one would have a lobster, the next one would have a crab. It went back and forth.
I have a question from YouTube from Bill Nagini. Said, how necessary were these southern constellations to navigation?
That was an important part of what Petrus Plancius was trying to do. It was important to navigation, and he wanted to have better pictures of the sky where he could depict the actual placements of the stars. So he trained navigators to get accurate star positions to aid the Dutch with their navigation in the southern hemisphere. Interestingly, the other guy who was supremely interested in navigation was Flamsteed, and he produced the first astronomer royal, produced a wonderful atlas in 1729. Actually, he was dead for 10 years, but it was, again, his wife did it posthumously. His atlas was intended to be helpful for navigation, but he wouldn't list a star if he couldn't see it from Greenwich. And so he didn't have the southern sky.
Can you see any stars from Greenwich? I'll take the prerogative here. I know the Polynesians had constellations, and they were kind of big, long things, and they used those for navigation. And apparently they were very accurate with it.
A lot of cultures, the Chinese have them, or had them. I've got an interesting chart from about, I think it's 1753, that has the constellations, the Western classical constellations, with the Chinese constellations overlaid the top. And so both sets of constellations are on those charts. It's interesting, but every culture had its own. The Japanese, I said, have Subaru as a constellation.
Now, how much concordance is there between them? Like, the different cultures see the same crab and the same bull?
No, almost none. Almost none. Anybody else? All right. Thank you.
Thank you.
Thank you so much.
Oh,
You still have the, yeah.
this is yours. We'll just like.
You have the mic.
On the mic.
The mic.
And the mic.
Oh, Bill wanted you to mention Cherry Springs.
Okay, we kind of did. Yeah, we talked about the church. Bill McGeeney on YouTube wanted to mention the Cherry Springs weekend. It's the same weekend as the sold out Black Forest. Right? And I said, we'll post the sign up for that probably within the next week or so. We're just ironing out a few details in the posting. And do you know the dates of the South Jersey Star Party that I didn't get on the slide?
Last weekend in September.
Last weekend in
September
September.
28th, like that.
Because that's another good one too. I just thought it was a little too far in the future, but. Okay, well, thank you, everybody, for coming. I realize I forgot to thank the judges who judged the youth submissions. I know, Jeremy, you were one, and we have,
No,
you weren't this year? Oh, okay. Thought you were. At any rate, thank you, whoever you are, I know. And thank you, Al, for championing this great program. I'm so happy to see the incredible research that our students are doing. And even though it might be happening, if we didn't have these awards, we would not know about it. And it's been, maybe we're even encouraging people to do the research.
South Jersey Star Party, September 26th to the 29th.
Thank you.
So
Okay, so the South Jersey Star Party is the 26th through the 29th of September at Belle Plaine State Park. Put that one on your calendar too. Okay, everyone, a couple of things. We still have some things for sale back there on the table. Feel free to take a look. And also, don't forget to check out the Sea Star, the star that can be rented before you leave tonight. Bye, everyone, and thank you.
Okay.